Hi, welcome to section 3.3 entitled Linear Equations and Their Graphs. Well, this thing here, I'm going to start in the middle like I usually do because the questions are more interesting in the middle and I work my way out. But this is a graph of what's called a line. A linear equation is a line. Now, why is that a line? Well, if I want to graph that, all you need are 2 points. What this basically says is, given a value for x, you need to calculate the corresponding y value. That's all this equation is telling you to do. Okay? Or you can go backwards and say, well, if you give y a value, what's the corresponding x? You have to do a little bit of a calculation because not every number works well with this equation. Like if I were to plug in 1, according to this line, if I were to plug in 1, y must be 2. It cannot be 3, it cannot be 5, because that would just make this equation not work. Okay? If you said this was 5 equals 2 times 1, that's not true. The only thing that would make it true is if x is 1, then you have 2 times 1, and if y is 2, then 2 equals 2 works well. Now, to graph, all you need to do is just pick a value for x and calculate the y, and all you need are 2 points. That's all you need. You don't have to do any more than 2. Now, I will tell you that I could pick x as 100, but that doesn't make any sense because the graph has no 100s listed on the graph. So what I would tell you is pick a normal number, a number that makes sense, a number that requires little effort to generate the point. The best number is to make x equals 0. See this? That's x equals 0. If I were to plug in 0, 2 times 0 is 0, y equals 0. There they go. That's 1 point. And we've already determined that if we picked 1, x is 1, y must be 2. Those are your 2 points right there. So how do you graph that? Click on the graph, make a line, and just like you did in the other section, you pick the 2 points that you generated. 0, 0 is one of them, and then 1, and I believe they even give you a little help on trying to find the point. So this is 1 horizontal, 2 vertical, boom. So the difference between this section and the previous section is the previous section they actually gave you the points and you graph the points. In this section, in order to graph the line, you need to generate your own points. Not a lot of work, you just have to do 2 points. Now, is that right? Sure, that's right. Let's go ahead and let's do this one. This one is unique in that you have a fraction. Okay? I always go for the x equals 0. Always go for x equals 0. Because 0 times anything will generate a 0, y must equal 0. So that's 1 point right there. Now the problem is this. The next easiest number would be 1. Because 1 times anything is that anything. 1 times 2/3 is 2/3. The issue with 2/3 is I cannot plot y equals 2/3. You can only do whole numbers here. So when you get in that situation, you can get a whole number by simply making x equal to the denominator of the fraction. So if I go ahead and I put in 3 there, that's the denominator of the fraction, because you get to pick whatever you want for x. 2 over 3 times 3, the 3's cancel, y must be equal to 2. Right there, must be equal to 2. Okay, the hard work is done. We've generated our own 2 points. Let's graph them. 2. 0, 0. That's 1 point. 2, 3 is another point. I like what I'm seeing here. Positive slope. That's a positive number. Check your answer. Whoa, what did I do wrong? Oh, Oh. Okay. This is okay. This is okay. It's a good thing we have multiple choices here because this point is 2, 3. The point I was supposed to plot is 3, 2. 3, 2. So let's clear the problem. Start over again. Ooh, I got egg in my face. Okay, 0, 0. Boom. 3, 2. Boom. Okay. Check your answer. Good. That's good. You know, just goes to show you, even Babe Ruth struck out every so often. Doesn't hit home runs all the time. But let's see if I can make up with the next question. I'm going to let you do this one. It's a fraction, so I'll let you do that one. But let's do this one with all we got y's and x's and numbers. Okay, that's good. And to do that problem, what I'm going to do is clear it, get a new sheet of paper. Don't save it. File, new, okay. I'm going to write that line down, y equals 4x plus 6. Okay. What do? We need to generate 2 points. Always go for the x equals 0 if possible. If x is 0, notice what I do. I set my points. This is always x and y. If x is 0, what does y have to be? Well, if I plug in x is 0, I get 4 times 0. That's 0 this term, plus 6. So 0 plus 6, y must be 6. Okay. The next best number is 1. Try to use that if possible. And I think we can, because if I plugged in 1 here, 4 times 1 is 4. 4 plus 6 is 10. So those are your 2 points. Don't beat it to death. That's all you need to do. So what I'm going to do is plot those points. Oh, there's a lot of grid points here. Luckily, we do have this. If I click on this, make a line. And I think, yeah, at the bottom here, you do have the point generator there. So I start in the middle of the world. 0, 6. Okay, 0 horizontal, don't move it. Just be careful with the mouse. Got to go up to 4, 5, and 6. Click that. I hope that's right. I hope I didn't move it. We'll find out. And then we've got 1, 10. 1, 10. Let's see if we get that point generator there. 1, 10. That's it. 110. Go click on that. Click on that. Check your answer. Very good. That's all you do here. That's all you do. Now I'm going to graph this one too, because this one looks different from what we just did here, in that we got the variables x's and y's on one side of the equation. And it really doesn't make too much difference. It's just that it looks different. And so I don't want to scare you too much with that. Okay, let's see. Let's write this equation down. Y minus 3x equals -2. Okay, let's see what we can do. Well, let's see. What I would do is what I've always said you should do. Try x is 0. X is 0. That's a beautiful number. You know why it's a beautiful number, 0? Because you've got to do the multiplications first. So what you have here is -3 times 0 is 0. Y plus 0 equals -2, so y must be -2. So you generated that point with relatively little effort. And then, again, I think it's okay to go ahead and try x is 1. As long as you don't generate a fraction when you plug in a value for x or y, as long as you don't generate a fraction, because you can't plot fractions on these graphs, only whole numbers, so you're limited to that. But if I plug in 1, I have this. I'll expand that one. Plug in the 1. Always do it with parentheses. Otherwise, it looks like 31. It looks like you got to multiply these two guys here. You don't need a calculator for that because it's minus 3 equals negative 3. And then to solve for y, the necessary y, you have to add 3 to both sides. Looks like I've got y equals 0. Those are your 2 points. Oh, wait a second. I screwed up. This is negative 2. This is supposed to be negative 2. I don't know why I wrote down negative 3. I've got to backtrack. Jeez. Let's go ahead and put negative 3 here. Negative 2. Negative 2. Okay. Sorry about that. Negative 2. Negative 2. So it's negative 3. All right. We're good. We're good. Negative 2 plus 3 is 1. 1. So those are the points. Something was weird. Didn't look right to me. Okay, there we got the points. So you got to be careful when you do your work. Even I've been striking out lately. What's going on here? Click. Make up line. 0, negative 2. Boom. Now remember down here somewhere there's a little line, a point indicator, so that should help you. I'm going to try to do it without it. 1, 1. Boom. There's your line. Check your answer. Great job. Good job. Fantastic job. Whew. Okay. What do we do here? What do we do here? What we do here is we start off with a fresh sheet of paper. That's what you do. In math, you need a lot of paper and a pencil. You write down the equation. Okay. This equation basically stipulates that if you pick a value of x, there can only be one y that is associated with that x, because that x and y has to satisfy that equation. And the same thing for y. If you pick a y value, there can only be one x that can make this equation true. Because ultimately, see, what's happening is this calculation of x's and y's, 2x plus 5y, has to equal 10. And there's only one combination of x and y's that does that. So here's what I'm going to do. I'm going to show you a neat little technique to do this. When you have your x's and y's on one side, what I usually do is I say, well, I'm going to pick x as 0 and calculate what the y value is going to be. Then the other point, what I do is I force y to be 0, and then I calculate what the corresponding x should be. Now, why is that so special? If I make x as 0, okay, 2 times 0 is 0. It's gone. That term is gone. You're left with 5y equals 10. And you can almost do this in your head. 5y equals 10. You divide by 5 both sides to solve for y. You have to get 2. Okay? Now here, y is 0. That destroys this entire term. It goes away. What's left is 2x equals 10, and if I divide by 2, I have 5. That's the beauty of 0. That's the beauty of 0 right there. And all you need to do is come up with 2 points. How you get those points, as long as they're valid, we don't care. Okay, start in the center. 0, 2. Boom. 5 horizontal, 0. There you go. Check your answer. Nice work. Nice work. Nice work. I'm going to let you do this one. I'm going to let you do this one. These are called, oh, by the way, these points here are special. They're called the intercept points. Let's go back here. Okay. This was correct. This problem was correct. But these 2 points that I calculated are called the intercepts. They cross the x and y axes, and those are the points that are called the intercepts. Okay, this guy here, this line crosses the y-axis at 2. That's the y-intercept. This guy right here, this is the y-intercept. Y-intercept. I'll call it y-int. This is the x-int, because that line crosses the x-axis right over there. Okay, and it crosses at 5. Now, if I say that the y-intercept crosses at point 2, it's implied that the x value is 0. See, a point is basically an x and a y. It looks like it's crossing at 2, and it does, but that's the y value that it crosses at. It implies that x is 0. So the y-intercept implies x is 0. The x-intercept implies y is 0. See, because when you cross this point here, this line crosses the x-axis at 5, it's implied that the y value is 0. And these are called the intercepts right over here. Okay, so come over here, and they say for the given equation, I'm going to do this one. Find the x and y intercepts. Oh no, that sounds scary. It's not scary. What you do is you just put the line down, put it on your paper. What they're asking you to do is what I just showed you up here. Set x equal to 0, find y. Set y equal to 0, find x. Now this is going to be the y-intercept right over here, because it's going to cross, there's going to be a number here, and that's where it crosses the y-axis, because that's the value of y, and that's the y-intercept, implies that x is 0. So here's what I'm going to do. I'm not going to do any side calculations here, nor should you. If x is 0, 6 times 0 is gone. You're left with this. Negative 4y equals 12. You can do this in your head. Divide both sides by negative 4 to solve for y. 12 divided by negative 4 is negative 3. Okay. That's done. That's the y-intercept. If y is 0, we cross this out. This whole term goes away. You're left with 6x equals 12. Divide by 6. You get the x-intercept to be 2. And those are the 2 points. Click this. Click this, make a line. What do we got? 0, negative 3. 0, negative 3. There's your y-intercept. And this is 2, 0. That's your x-intercept. Go for it. Excellent. Nice. Intercepts are fun. Intercepts are fun. And this, so I'm going to, this problem here looks like what I just did, only it has different numbers. So I'm going to leave you with that. I want you to have some fun. I'm going to plot this one. These are weird cases. This is a weird case. Let me get some new sheet of paper here. File, new. Okay. Come over here. This is weird because it doesn't have x and y. It's only got one variable. It's actually easier when you have both x's and y's in the problem. It's just a little weird to have only one variable. And what does that mean when you plot it? So I'm going to put that down. Now in this problem, there's only one variable, and so the concept of saying plug in x for 0 and calculate y just goes out the window because there is no x. So how do you do this problem? Well, this is why I call this one of those little fringe oddball problems. But still, the idea is the same. You only need to generate 2 points. Okay? So I'm going to get my points ready like so. Here's my 2 points. I'm getting them ready. What this is saying is the y values of those 2 points doesn't depend on x because it's not even mentioned. the y values have to have, the y values of those 2 points have to be -2. That's what that says. There's no calculation involved. Y equals -2, those 2 points must have y values equal to -2. X is not involved in any type of calculation because there is no x. Now what do you put here? Put whatever you want. Don't put 100 because you can't plot 100. 0, 1, those are beautiful numbers, normal size numbers. And those 2 points are all you need in order to plot that line. So let's see what that looks like. Click. Line. 0, -2. Click. 1, -2. Click. That's a horizontal line. Horizontal line. By the way, you should memorize this or put this in your notebook or do something. All y equal equations are horizontal lines. All of them. Okay? If you're not getting horizontal lines. I can't spell horizontal lines. All y equals. Okay, so let's go ahead and say, what's the next one? I bet you there's an x equals coming up next. Good job, yeah. Next, ooh, yep. Guess what do you think? What do you think an x equals is going to look like? Okay, I'll tell you what it looks like. A vertical line. Vertical line. AL. Okay, x equals 6. Get my 2 points ready. Same deal here. There is no y even mentioned. If there's no y even mentioned, then there's no calculation involved. This is basically saying those 2 points have to have x values equal to 6. And you get to pick whatever you want those points to have. I'm going to have for y values 1, 0, and 1. Now let's see if that works. 6, 0, bing, right there. 6, 1 is just one up. That's it. That's a vertical line. Vertical line. Clear it. Excellent. Nice. Nice. We banged that out pretty quickly here. So remember, y equals are horizontal lines, x equals are vertical lines. If you have both variables, there's a slope to them, and you need to do calculations to calculate the x and y values. Okay, what's going on here? This one here is a new sheet of paper. Now, this doesn't look too bad. The only issue here is you have a fraction. Okay, well, we can do fractions. 1/2 x plus 8. Okay. Oh, what am I doing? This is, oh, geez. Let me do undo. Edit, undo. Edit, undo. Control Z. Okay, that's going to be 2x plus 8. Okay. When you have a y equals an expression like that, I go with simply saying, well, set x equal to 0. 0 times 1/2 is 0. Y must be 8. There's no calculation involved. Now the problem here, don't go with x as 1, because if you go with x as 1, you're going to have a 1/2. Plus 8 is 8.5, and you can't do halvesies on this graph. It's all whole numbers. So what did I say you do? You just take the denominator and have x be equal to 2. So that when I do plug in 2, I get 1/2 times 2. The 2's cancel, leaves you with 1. 1 plus 8 is 9. 9. There's a 2 points. Okay, let's plot them. Graph, line. Okay, 0, 8, 0, 8, 0 horizontal, 8 vertical. Then we've got 2, 0, 1, 2. Not 2, 0, 2, 9, 2, 9, 2, 9, 2, 9. That would be 2, 9. Boom. Check your answer. Good job. Good job. Okay, I'm going to let you do this one here. We did this one. I think we've done one like this. All right, we've done one like that. I'm going to let you do that one. Okay, some word problems. Only one word problem? Good. Don't do too many word problems. A young couple buys an appliance for $740, agreeing to pay $20 down, that's all, and $30 at the end of each month until their debt is paid. Express the amount paid in terms of the number of monthly payments. Okay, here's what you're going to do. They put down $20 right off the bat. Then we're going to add to that $20 $30 for every month that goes by. So if M is 1, you pay $30 plus 20, 50. If M is 2, you make two $30 payments. $60 plus 20 is 80, etc., etc. That's the nice equation for that. That equation would do the job. Now, what does that? Complete the following table. Okay. If M is 1, you made one payment. That's going to be $50. If M is 2, you made two payments. $60 plus another 20 is $80. And for every month, you're just adding 30 to the previous number, 110. Check your answer. Good job. And that's done. We have to plot it. We have to plot it. So let's see if we can make this a little bit bigger. Try to get as much as we can there. Okay. Click. Okay. Make a line. All you need are 2 points. I know there's 3. Pick two of your favorite points here. I'm going to pick the first 2. Okay. I'm going to say M is 1. P is 50. Okay, see the P over here? P is the vertical. M is the horizontal. Okay. I'm going to pick M is 2. And the P has to be 80. Click. That's it. Don't bother with this third point. That's it for that guy. Now, I think we skipped a few. A few we intentionally skipped because I wanted you to do them. I think we're going to go back to question 1, 2, and 3, and then we're done with this video. We're done with this video. Come back to question number 1. Okay, basically, all right, here's what this says. Let me copy this down. Start with a fresh sheet of paper. File, new, fresh sheet of paper, okay. Okay, let's write this equation down. They're not actually asking us to plot anything. What they're doing is they're saying, okay, they want you to get used to the idea that only one set of values of x and y work when you're dealing with lines. So what that means is this here. They want you to plug in x is 2. There can only be one corresponding y. How do I calculate that y? You simply plug in the 2. 9 times 2 minus 6 is going to be equal to 18 minus 6, and that's going to be equal to 12. So the point 2, 12 is a point that's on this line. So I'm going to put a 12 there for y. So let's do that. And then for the 5, x is 5. X is 5, so everywhere you see an x, I put a 5. Minus 6 is 4. Okay. Do your order of operations. 9 times 5 is 45. Minus 6 is 39. And so the point would be 5, comma 39. Let's put a 39 over there. Now be careful here. Okay, they're saying set y equal to 0. Not x, y to 0. So you go up here in their equation, set y equal to 0, and figure out what x is. Y is 0, what's x? Okay. Solve for x. Add 6 to both sides. And then divide by 9. Cancels. X equals 6/9. But 6/9 is not simplified. Notice I said simplified fractions here. You got to divide top and bottom by 3 to get 2/3. Okay. We haven't done much with fractions as far as answers because we're not really plotting anything, but mathematically 2/3 is going to be the answer that you need to plug in there. Now, I'm going to let you do this one. I'm going to let you do this one. You have to have some fun on your own. And last but not least, I'll do this one, number 3. Yeah, we did that. Okay, number 3. Let's do this one. Start off, don't save. Because there's a fraction in the problem, so that's why I'm doing that. New, okay. What do we got here? Y equals, put that down on your paper. You know you're going to need that to do some calculations. Now, let's see. Notice what they're doing here for x. They're making sure x is a multiple of 7 because when I plug in 7, when x is 7, I calculate the corresponding y. See, when x is 7, parentheses, see the 7's cancel, leaves you with 1 minus 1 is 0. So I'm going to put a 0 there. When x is 14, 1 over 7 times 14, plug it in, minus 1. 7 goes into 14 2 times. 2 times 1 is 2. So that's going to be 2 minus 1 is 1. Now be careful here. Y is set to -2, not x. So y is set to -2. So I'm going to take this equation, set -2 for y, and calculate what x has to be. Well, get rid of the minus 1. Plus 1 both sides. Plus 1 will get rid of the minus 1 here. Do the opposite. So if I do plus 1, I get -1 equals 1/7 x. Now I got to multiply both sides by 7 because x is being divided by 7, multiply by 7. So I'm going to multiply both sides by 7. I get -7 equals x. That'll be -7 up here. And then the next thing I'm going to do is, geez, let's see if I can put it over here, sneak it in there. Make y equal -1. -1 equals 1/7 x minus 1. Same deal, I'm going to add 1 to both sides. 0 equals 1/7 x. Multiply both sides by 7, you get 0. Because if I multiply this by 7, the 7's cancel. 7 times 0 is beautiful. 0. I'm going to check my answer. That's it. Okay, I think we did enough here. Let's see, I think we skipped a few of these problems. Yeah, I want you to do question 2. Question 6 is, yeah, that you can do that one. And check question 11. Yep, you should do that one based on what I just talked about. Number 15. Yep, you can do that. All right, so do that. And I guess, remember, there's a quiz that corresponds to 3-1, 3-2, and 3-3. Do that. Do that quiz. All right, we'll see you in 3-4.